Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 9D. Myself, Richa Shah, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the ninth International Conference on Smart Trends in Computing and Communications, that is SMARTCOM 2025. The ninth edition of this conference has been organized in a hybrid mode. The physical event was held yesterday in Pune, and the virtual event is being held through Zoom on 30th and 31st January 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations, and each presenter will be given 8 minutes for the presentations and 2 minutes for question and answers. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. So before we start the session, I'd like to introduce you all to our session chair, Dr. Shalini Puri ma'am. Ma'am is an associate professor in the Department of Information Technology at Manipal University, Jaipur. With 20 years of teaching experience and 11 years of research experience, she specializes in machine learning, artificial intelligence, and image processing. Dr. Puri has published around 31 research papers and actively participates in national FDPs, workshops, and training programs. Her research interests include machine learning, image processing, pattern recognition, and artificial intelligence. Welcome to the session, ma'am.
Thank you, ma'am. Thank you so much.
Moving on next, we'll be starting with the presentations. So I'd like to call Mr. Srihara Deshmani for his paper titled A Survey on Gen AI and Encoders for Video Generation Using Multimodal Inputs. Sir, can you please start with your presentation?
So good afternoon to everyone. My research on generative AI and encoders for explores how AI-driven models can generate realistic videos using images and text inputs, highlighting key advancements, challenges, and future directions. So this research explores how generative
So are you
AI
speaking because
encoders
you're not audible?
based architecture are transform video generation. We analyze how CNNs, RNNs, and I'm not audible.
Sorry, my
Hello?
bad, you're audible. It was a connection issue from my side.
Okay. So the research explores this research explores how generative AI and encoder based architectures are transforming video generation. So we analyze CNNs, RNNs, and transformers enable extraction features and sequence modeling. So we also discuss GANs, which are generative adversarial networks, which help sequences. So finally, we identify the key challenges in integrating multimodal inputs and propose a solution to improve realism and coherence and integration. So,
Hello, voice is not audible.
so to build a strong foundation for encoder-based architecture such as CNN.
So you have some issue from the connectivity, I guess, because it is not audible.
Am I audible? Am I audible?
You can continue the presentation later on. We can take another presentation right now, if that's fine for you. Hello. Does that work for you? Can you write it in the chat if your voice isn't audible? Okay, so meanwhile, we can go to the next presentation. I'd like to call Mr. Vatsal Tamewar for his paper titled Accelerated Facial Aging Using GAN. So please can you start with your presentation? Yes, so you can start.
Okay. So, first of all, good afternoon, everyone. My name is Vatsal Tamewar, and my currently paper I have released is a survey paper which focuses on facial acceleration of faces, facial aging acceleration using GANs. So, basically, in this, the overview would be the survey paper like it focuses on the current state of the art methods in facial aging using GANs, which we have multiple GANs available for using the facial acceleration. Facial acceleration basically means after post 20 to 30 years, what would be the current state of your facial structure? Like how old you would be, how old your skin muscles would be, what would be the bone structure and all. So this focuses on that. And basically uh, we have also discussed the challenges and limitations uh, uh, occurred in most of the papers that include the dataset biases, loss of identity, and computational efficiency. The dataset biases basically occurs due to the lack of the data of the facial structures of the humans. As I have also seen most of the data sets. One of the dataset I have observed is the UTK face dataset, in which most of the images are from the out of the India people, abroad people. We are not having enough images of the Indian people, so that produces an ambiguity in developing the output. The basically applications are the widely used in forensics, entertainment, and age invariant facial recognitions. And also, we have also studied different GAN architectures and studied their metrics and their advantages. The aim was on researching and studying on the latest GAN-based facial aging techniques. We studied multiple models here, like cycle GAN, star GAN, and then uh, CFA GAN, and more. Multiple GAN models we have studied, and each model have their pros and cons. The survey paper was based on researching on the most of the GAN models which focused on identity preservation and achieving high fidelity age transformations. And we aim to contribute to the field by addressing the dataset biases, computational efficiency challenges, and the performance parameters which are involved in the finding of the facial aged images. So basically, in the introduction part, I would say the three main parts would be facial aging, which is the main topic of our paper. Then the aging simulation, that we will try to simulate the real life aging span or aging process by using GAN and applications. So basically, GAN, I can say that GAN is a type of an ANN, and like as we know that ANNs are the backbones of GANs, which are also used in age progression and regression. ANN is basically used for extracting the facial features and the preserving of the identity of the feature and generating high quality images and many more. So basically, ANN works like the structure of a human brain, which adapts the input, transforms according to it, and the output is produced much more efficiently. So also we know that the nodes in this are called as neurons, which make resemblance with the human brain. Then CNN. CNN is an advanced version, we can say that, of ANN, which include multiple layers in that. As we know that in ANN, we only have pooling layers, but in CNN, we have fully connected layers, pooling layers, convolutional layers, which increases much more efficiency of the uh, of the model. Basically, in the GAN, a GAN is a type of CNNs are used in GAN for generator and discriminator. I would come to this point later on in the block diagram. And as I said before, in the ANN, GANs help us to learn the age-related features like wrinkles, skin tone changes, and facial shape variations. And CNNs, the most favorable quality of the CNN is that it improves identity preservation. So basically, the it's a general block diagram of how a GAN works. The first of all, an input image is provided, the data set of images, which is an input image. Then the input image is pre-processed in the form we want, like the dimensions we want, the cropping part, the image processing part. So removing the redundancies, like removing the spotlights and all, and the data is pre-processed. After the pre-processing, the data enters into the GAN architecture. GAN architecture basically consists of a generator and a discriminator. It's a constant war between a generator and discriminator, as generator tries to generate an actual image using the random noise to try, and it tries to fool the discriminator, and discriminator always discriminates which is the real image and the fake image. uh, According to that, the generator adapts and learns how to generate a facial image using the discriminator's output. And the moment the discriminator is fooled by the generator, we come to know that the generator has exceeded the capability of the discriminator, and all the image set is also again provided to the data set of the discriminator so as to improve it more again. So knowing that the images which were produced, which was given as the status of true and real images by discriminator, were actually false, and the discriminator is trained once again. So this is the constant looping training of the procedure, which improves the efficiency of the model. So these are the main parts in the like the GAN, that is generator, discriminator, and the training loop, which uh, which is continuously going on until the training process is run. So why GAN? First of all, there are multiple technologies, but still, why GAN? So first of all is the image morphing. Morphing means blending of two aged images. Like we can say that we have seen the Snapchat or Instagram filters. We get to know that the efficiency is not that much. Like when the distance from the camera is variable and the images are moving, so we come to know that the reference images and the actual images are not binded correctly. So why GAN is better in this phase? Because learns the aging patterns and not the blending of the image. Then the 3D facial models, the 3D facial models like we have seen in the movies, like Mission Impossible of the Tom Cruise. So we came to know that 3D facial models require the computational expense. It is very computational expensive, as the geometry and the mathematical formulas and calculations are highly intensive. So why GANs are better in this? Because GANs work in 2D images, and it achieves the results which are lifelike results. Then CNN-based regression models, which predict the aging features. It has limited realism, and it lacks the fine-grained textures. As we know that CNN solely cannot produce a high-fidelity image compared to the GAN, because we use two CNNs like generator and discriminator in GAN, which in the constant training loop it improves its efficiency more over the time. And then rule-based approach. In the rule-based approach, there is not such a criteria, or there is such a not a rule of how a human will age. Every human ages in a different way, so there are no handwritten or hard rules which are to be followed. So GAN, in this structure, GAN is better, because we know that GANs learn automatically the aging structure, the skin structure, muscle structure, and the bone structure, how a human ages. So in this way, the GAN is much more better than the previous technologies which are residing. The specific goals which are to be achieved are the accuracy, like a high fidelity image. It should have a high resolution image, and it should give a realistic kind of output. Then diversity, the model has to be trained in a diverse data set to achieve the images of all the areas of all the regions of the world. And efficiency, as we know that efficiency is much more needed, so as to get the correct image.
Excuse me, sir. Sorry to disturb you, but 7 minutes are over. Can you please wrap up?
Yes, ma'am. So, for technique for preparing the models, prepare the image is cropping, resizing, and normalization. Real world applications are entertainment, like we know about the CGIs in the applications in healthcare to study the facial structure and the what disease can cause the aging in at what factor. And the marketing, as marketing we know that for expressing the beauty products and how the facial aging it can avoid. The challenges mostly occurred in the training are identity preservation, dataset bias, temporal consistency, which is basically smooth transitions over the different age groups, and computational efficiency. The future scope are higher resolution images, improved identity preservation, and forensic healthcare applications. So yeah, so that's from my part, and the conclusion is that the facial details should be accurate, avoiding unfair bias in training data, and making sure that face ages naturally over time. So these are the references, and yeah, that's from my side. Thank you.
Okay. My question is, what are the most commonly used datasets for training and evaluating facial aging gains?
Most commonly used, actually, we have searched for the data sets, and one we got to know is one like we have seen is the UTK face data set, which we got from the Kaggle.
Okay, what was the size of the dataset? Have you seen that?
Like actually, may I refer that I am having the data set? I'll tell you in 1 second. The UTK face dataset consists of around 23K images, including from the baby faces to the young faces, like old faces.
Okay. My other question is, like aging is influenced by genetic, environmental, and lifestyle factors.
Yeah.
So, how do current GAN-based models account for these variables?
Sorry, can you ma'am please rephrase your question?
As you know that aging is influenced by, genetic, environmental, and some lifestyle factors.
Yeah, yeah.
So, how do current GAN-based models account for these variables?
Actually, the models which we have studied only currently focuses on the natural aging and not the environmental factors and the genetic factors.
Okay.
Yeah.
So only, okay, fine. Okay, thank you so much.
Thank you, ma'am.
Thank you for your presentation, sir.
Thank you.
As the previous presentation was stopped midway because of internet connectivity, so I'll ask them to continue it.
Okay, thank you. Survey on generative AI techniques for video generation. So most existing models focus on either image.
What has left the meeting, so probably we can move on to the next presentation. I'd like to call Mr. Abhishek Masne for his paper titled Bone Fracture Detection Using Machine Learning. So please can you start with your presentation? Abhishek, sir, can you start with the presentation?
Yes, ma'am. So, good afternoon, everyone. My name is Abhishek Masne, and I am excited to present my survey paper on bone fracture detection using machine learning. First of all, I would like to extend my gratitude to the organizers for this opportunity, and also let's begin by understanding the problem we are trying to solve. Am I audible, ma'am?
Yes, sir, you're audible.
Thank you, ma'am. So, bone fractures are one of the most common injuries worldwide. Like millions of people suffer fractures every year. Let's say due to accidents or aging, or let's say any sports injuries might be. So, while traditionally doctors analyze the X-rays by identifying the fractures manually, and while this method has been reliable for decades, but it comes with several challenges like subjectivity. Let's say two radiologists may interpret the same X-ray image differently, which can lead to inconsistency diagnosis. And secondly, manually it is time consuming as well. Reviewing hundreds of X-ray images per day is exhausting somehow. And the third and the most important thing is misdiagnosis. Let's consider the small fractures or the hairline cracks can sometimes be overlooked while manually judging the X-ray, which can lead to incorrect treatment. But with advancement in artificial intelligence and machine learning, we now have the ability to automate the fracture identification of bones using several deep learning models, which can assist the doctors and make the treatment faster and more precise and more accurate. Let's move. So that was all about the problem statement. And yes, objectives. Our research actually aims to address the uh, challenges with the following objectives. Let's say uh, develop an model which can identify the fractures, which can also identify the bone fractures with hairline fractures. And second objective is implementing a two-step classification approach. First, identifying the bone type and then detecting the fracture in the bone. And the third objective is create a user-friendly interface which can be interactive and user-friendly for the user to upload and diagnose the X-ray image. Uh, yes, minimize. This is all about the block diagram. So first of all, the input images, let's say, however, it may be damaged or it may be uh, improper, it is to be taken as an input. Then thereafter, we are applying some image processing techniques like resizing, let's say grayscaling and normalization, etc. Thereafter, we are getting the optimized image, which is then used to train our model and extract the features like textures, like ages and bone density, etc. This features is used to train the model, and we have used a data set which consists of about 20,000 X-ray images, and which is used to train our model. Thereafter, this model will be tested and validated on the untested images, and monitoring the performance and developing a GUI is the key objective. Yes, that's data set. For this research or the project, we use the Mura dataset, which is one of the largest publicly available X-ray datasets for musculoskeletal analysis. Like it has more than 20,000 images, X-ray images, and which majorly focuses on shoulder, hand, and elbow. Yes, image preprocessing. Like medical images often vary in contrast and brightness and size, maybe some distorted images. If we feed this raw images directly into the model, the result may not be that accurate. So to overcome this, we applied several pre-processing techniques, and few of them are like data cleaning. Then data cleaning is basically used to remove the duplicate and handling the missing or corrupted images. Then resizing is another important pre-processing, like standardizing the image dimension for consistency. Then we have normalization. Normalization means scaling the pixel values to improve the model performance. And then we have applied the data augmentation techniques as well, like we increase the size of the data set by introducing variations like flipping the images and rotating somewhat images by a few degrees and changing the contrast in the images to make our model more robust about the classification. Once we had the clean data set, we moved on to the selecting the right deep learning model. Yes. For this, yes, there was one more point added to this image processing. We have divided the dataset into three categories. That is training data for the training purpose. We will
So, just a gentle reminder that 7 minutes are over. Can you please wrap up?
Sure, ma'am. Moving on to the main part, that is the deep learning models. Convolutional CNN models are widely used in medical image analysis due to their ability to recognize patterns and textures in images. So for our project, we have tested three CNN architectures, that is ResNet, DenseNet, and VGG. I was earlier talking about the two-step classification. So here it is. Step one is bone type classification. That is the identification of the bones of which part we are actually referring to. And the second step, we will be identifying the fracture in the bone. Yes. So talking about the model performances, ResNet, we actually achieved 92.4. That is the highest accuracy in ResNet model. And then the second was DenseNet, which actually matches the accuracy near about, and VGG lacks a bit in that purpose. So conclude talking. Let's get to the conclusion. To summarize, our we have successfully established a foundation for automated bone fracture detection system using machine learning, and we can save millions efforts of doctors and save a lot of time. And the future scope of this project includes improve the model robustness for real world medical images and expand the data set with more diverse accuracy. And these were all the references that we referred to. And thank you. I'm
Okay,
open to
Abhishek. I want to ask, what are the key challenges in deploying this model in clinical practice?
Yes, ma'am. So key challenges would be like sometimes it is more feasible to actually have the doctor's prescription if the x-ray is properly understandable, but if there are hairline fractures, then that thing is a bit complicated in that case. So that is to be taken care of. And sometimes we need to focus on uh, what else? Uh, for fine hairs, this model can be used, but if the fracture is very visible by the doctor itself, then that's a easy way out. But for fine hairs, it is a better approach, I think.
Okay, my another question is, how well does your model generalize to unseen data, such as X-rays or CT scans from different hospitals? I mean, you have taken some data sets, so are you planning to extend your data set in some way?
Uh, ma'am, for now we are only focusing on
Hello? Hello?
So you're not audible. Um, Abhishek sir, are you able to hear us?
yes,
Can you?
ma'am.
Yeah, ma'am had asked some question.
Uh, Ma'am, I guess I was not audible. Sorry, ma'am. Uh, can you please rephrase the question, ma'am? Kindly.
Yes, please. I was just asking, like, if you want to generalize your model to some unseen data, say X-rays or CT scans, etc., from different hospitals. So how can you do that? And my another question was like how you are planning to extend your data. I
Yes,
mean,
ma'am. So, for now, we are only referring to X-rays. We are currently not focused on the CT scans or MRIs. So, we have trained the data model on X-rays basis. And uh, talking about improving the data set quantity, so we have applied some data augmentation techniques like rotating, flipping, and adjusting the contrast and brightness. So through that techniques, we have improved the size of dataset, which can be helpful for training our model on an efficient manner. Uh, was I audible, ma'am?
Yeah, you were
yes,
audible.
yes,
Yes.
yes. Okay, thank you.
Thank you, ma'am.
Thank you for your presentation, sir.
Thank you, ma'am.
Moving on next, I'd like to call Sneha Suman ma'am for her paper titled Compad in Deepfake Image Detection, Techniques, Comparison and Challenges. Ma'am, please can you start with your presentation?
Hello.
Yes, you're audible.
Okay. So good afternoon, everyone. I am Sneha Suman, and I'm glad to present our review paper titled Compared in Deepfake Image Detection Techniques, Comparison, and Challenges. So, in the background, as we know, artificial intelligence is a buzzword nowadays. It is a combination of technologies that enables machine to learn, understand, and act like humans. Deep learning is a subfield of this. Advanced techniques in deepfake learning, like generative adversarial networks, the GANs, are being used to digitally manipulate the original content and to produce deepfakes. They opened up many opportunities along with some serious consequences. Sometimes a small intentional change is added in the data point, and that these changes are undetectable to humans and confuse the learning model. Compressive adversarial perturbations aim to make these changes even smaller and harder to detect. The compact techniques that is a framework which is used to detect adversarial attacks. In in this review paper, we aim to offer a comprehensive survey of the various deepfake detection techniques that have emerged in response to these challenges. Our goal here is to provide both the current landscape and a forward-looking perspective on where the deepfake detection techniques research is headed to, with a particular focus on enhancing the robustness, scalability, and generalization. Okay, so moving on to the literature review, where we will discuss those techniques and works that based our review paper. One paper introduces a deep learning based method using ResNet 50 to detect the deepfake videos by identifying face wrapping artifacts which outperform the model like two stream neural network mesonet and headpose by up to 21% on these data sets. Another paper here explores the impact of distribution mixes and quantile mixtures on model uncertainty. There's some authors also combine the hybrid optimization techniques like particle swarm optimization and genetic algorithms with deep learning for faster convergence and robust detection. Here, this paper explores the risk of adversarial instances that can deceive deep neural networks and discusses methods for generating adversarial examples, the need for standardized benchmark platforms, and the ongoing arm race between attack and defenses. In one such paper, it reviews the progress in four deepfake creation techniques: face swapping, face recreation, talking faces, and facial attribute editing. Uh, this paper also discusses a technique uh, like D4 that stands for destroying diffusion deepfake detection. Uh, it is discussed as an ensemble of models working on different frequency spectrum subsets to enhance robustness against adversarial perturbations. Uh, Convolutional neural networks are also used, like DesNet 1 to 1. It is used for detecting deepfake images and also achieves a accuracy of 93.24. Techniques like vision transformers are used for image analysis by focusing on small patches and combining patch embeddings with the CNN features. Self-supervised contrastive learning are also used for training on unlabeled data, which improves resilience to image distortions and generalization. Moving on to the methodology, we use a very simple methodology by focusing on recent improvements in the deepfake identification and adversarial defenses. Our sources were from reliable websites like ResearchGate and ARXIV. Some of the main approaches that we come across uh, in the compared framework that detects the small perturbations in deepfake, but it struggles with the high resolution videos. CNN based models like ResNet 50 also improves the accuracy, but the performance drops with the video resolution. Hybrid optimization that includes the particle swarm optimization and genetic algorithm uh, techniques that are used for better real time detection. The disjoint diffusion defect detection, the D4 method, uses the frequency spectrum ensemble to resist the adversarial attacks. Vision transformer is also used, and last but not the least, the self-supervised gas transformer combines the contrastive learning and GCNs for better generalization and transparency in the model. Here in the result, we found some key learnings such as improved model accuracy, which means the CNN shows better performance in detecting deepfake compared to the older models. Hybrid approaches boost performances like PSO, and the genetic algorithms that we talked about. The vulnerabilities to attack: current detection models are susceptible to adversarial attacks, highlighting the need for better defense standards. Challenges with the GND fake: the GANs are very capable to create more realistic deepfakes and detecting them, especially with the advanced generation techniques. Techniques like frequency based methods also improve the resilience of the detection models, and tools like GradCam helps in improving the interpretability and transparency of deepfake detection models. Going to now combining sorry. So now to summarize our work, we have seen techniques in five broad categories. The convolutional neural networks, which uh, which are used for detecting the deepfake in videos and reducing the need for larger training set. We have seen ResNet 50 model, which is used. We have the optimization approach, which enhances the detection by optimizing the weight and model parameters for robust performance. We have the deep neural networks, which discusses how they are susceptible to adversarial attacks, and the highlight it highlights the need for the robust standardized benchmark platform for deepfake detection. The generative and discriminative models, the GANs, and the variational autoencoders and the diffusion models are used for the deepfake detection, and the disjoint diffusion deepfake detection. It also focuses on detecting.
Excuse me, ma'am. Sorry to disturb, but almost 7 minutes are over. Can you please wrap up?
Okay, it's just okay, it's over. So for the conclusion, here are some key takeaways. Um, like combining multiple models. Here, these are kind of our suggestions. Combining multiple models also enhances the detection of deepfake content and improves the overall accuracy. Uh, Optimized models can significantly improve the model robustness by fine tuning the parameters and the weights. The need for robust benchmarking and standardized benchmark platform are essential for consistent performance evaluation. In future detection, we can see the combination of advanced general generative models with assemble techniques shows promise in overcoming the detection challenges. So thank you. It's over. I'm done here.
Thank you for your presentation, ma'am. Any question from the session chair?
Yes. Okay. I want to ask, what are the biggest upcoming challenges in the deepfake detection? So have you identified through the research papers?
Yes, we can say generalization uh, is a common challenge, and we have seen the scalability as there are a number of deep fakes, and there are they have different type of resolution, and they have different type of data set. The size is also varying, so the standardization and benchmarking and scalability, these are the major challenges that we have.
So how do recent studies address the interpretability of deepfake detection models?
Um, can you rephrase it?
Like you have gone through many
Mhm.
research papers, right? So
Yes, ma'am.
they addressed the interpretability of the deepfake detection, etc. How the issue of interpretability was addressed in in different models.
Uh,
Anyways, it's okay. Thank you.
okay, I'm sorry.
Thank you for your presentation, ma'am. Moving on next, I'd like to call Ms. Krisha Zalaria for her paper titled Comparative Study of Object Detection Models for Enhanced Real-Time Mobile Phone Usage monitoring in restricted zones. Ma'am, please can you start with your presentation?
Yes. Can you see my screen?
Yes, ma'am. You can start.
Good afternoon, everyone. My name is Krisha Zalaria, and I'll be presenting for our research at this conference, SMARTCOM 2025. The title of our paper is Comparative Study of Object Detection Model for Enhanced Real-Time Mobile Phone Usage Monitoring in Restricted Zones. This work is co-authored by Jaitet Singh and Dr. Priyanka Patel. Now, to begin our discussion, let's discuss this problem statement first. The widespread use of mobile phones in restricted areas such as hospitals and educational institutions leads to critical challenges. These includes privacy breaches, interference with sensitive equipment, and potential safety hazards. Now, monitoring mobile phone usage in such zone is crucial to ensuring safety, privacy, and compliance with rules. Effective monitoring helps maintain security and prevent unauthorized disruptions in these areas. With this in mind, the key objective of our research are to evaluate state-of-the-art object detection model for real-time mobile phone detection, to identify models that balance accuracy and efficiency, and to develop a robust system for enhanced surveillance in sensitive environments. Now let's discuss the related work on this domain. The first study, published in 2020, explored the use of SSD and faster RCNN models to detect mobile phone usage in both office and outdoor settings. These models were tested across diverse environments and to evaluate their effectiveness. The second study, conducted in 2023, focused on classroom monitoring using the YOLO V3. This approach enabled real time alerts for authorities, making it an effective solution for enforcing mobile phone restrictions in academic settings. Finally, another 2023 study used CNN based monitoring to detect mobile phone usage in examination rooms. This method aimed to prevent misconduct by ensuring strict surveillance during exams. These existing studies provide a strong foundation for our research. However, we aim to improve upon them for evaluating multiple models and optimizing detection accuracy in restricted zones. Moving on, let's discuss the methodology that we used. Here, let's explain the workflow of a research project which focuses on detecting the phone usage and using the images and the videos as the data set. First step is the data collection, which our dataset consists of two sources: mobile phone videos and data phone images. We used video framing to extract frames from the video, followed by image processing to enhance them. This result is a set of output images and are used for further processing. Next, we annotated the collected images using the CVAT, and annotation process involves labeling the images into two categories. First, person using the phone, and the second is person talking on the phone. This is because that some restricted zones allow person using on the phone but doesn't allow the person talking on the phone, and vice versa. This ensures that our data set is well structured for training. Data preparation is the third step. After annotation, we perform image augmentation and pre-processing. This helps improve the diversity of the data set and ensures better model performance. The fourth step is model training. So once the data set was ready, we use it to train our model, actually multiple models. These models learn to differentiate between the two classes based on the features extracted from the images. Sorry. Model evaluation is the fifth step. Finally, we evaluated the trained model's confidence in classifying new images, and the model is tested to check how accurately it can distinguish between the two categories mentioned above. Coming towards the purpose of this project, the primary goal of this project is to provide a scalable and accurate solution for mitigating the mobile phone usage in sensitive areas. To achieve this, we focus on real-time detection mechanism that minimize latency while maintaining the high accuracy. Enhancing surveillance. Mobile phone misuses in restricted areas uh, raises both privacy concerns and safety risks. Our solution empowers institutions with AI driven monitoring tools that seamlessly integrate with existing security systems. This model is highly adaptable, making it suitable for diverse environments such as hospital, classrooms, religious sites, etc. And now the real world impact. This technology promotes safer and more secure environment in restricted zones with its potential for large scale adaptation. Our system can help enforce policies in high security areas, ensuring better compliance and public safety. In summary, this project is not just about detecting mobile phones. It's about creating a smarter and a safer and more controlled environment using AI powered technologies. Now we're talking about the techno stack that we used. For the algorithms, we basically worked on YOLO V8, YOLO V9, efficient det, and the RCNN. And for the backend, we use Python and TensorFlow. The dataset we used was one from the IIT Roorkee, and other we augmented that with our own custom dataset. Now talking about the results. So, based on our research, YOLO V8 and YOLO V9 outperformed every other models present, which is efficient at and faster RCNN and mask RCNN. And the most effective one found was the YOLO V9 with an precision of 0.87, a recall of 0.83, and a F1 score of 0.85. Now, for the conclusion, this study demonstrates the effectiveness of YOLO V8 and YOLO V9 for real-time mobile phone detection in restricted zones, and these models are often an optimal balance for accuracy, speed, and adaptability, making them well suitable for the surveillance applications. The two class detection frame significantly enhances monitoring precision and flexibility, ensuring compliance with the security policies. Moving on, the future work that we are aiming to do is the dataset expansion to incorporate a wider range of diverse and complex scenarios to enhance model generalization and to improve the data accuracy. And the second is model optimization, explore hybrid models and advanced optimization techniques to achieve faster interference inference while maintaining high detection performance. And obviously the mobile application, so develop a user friendly mobile app to enable on the go monitoring of the restricted zones and areas, ensuring that real time detection and alerts. These are the references that I used for the PPT. Thank you.
Okay, my question is, what were the main challenges encountered when you deployed this model for mobile phone usage monitoring in restricted zones?
Ma'am, earlier we were just using the IIT Roorkee dataset, but that dataset conducted for only 1,000 images, and hence it was not enough for our models. So we collected more images, more videos, and then connected the images out of those videos and expanded to the dataset. uh, Other the main difficulty which we faced was that videos generally don't have a prominent figure showing that the person is using the phone or talking on the phone, so that was a little bit of difficulty that we faced.
Okay. And how did environmental factors like lighting or camera positioning affect detection accuracy?
Uh, yes, ma'am. It was also one of our main concerns, and that's why we tried to collect all sorts of images, which have both have we have which have both the low lighting and shadows, and also the glares and the overexposure sometimes. So we trained the model based on those images too.
Okay. Okay, thank you.
Thank you, ma'am.
Thank you for your presentation, ma'am. Moving on next, I'd like to call Mr. Aniket Gupta for his paper titled Echo Cart, Voice-Based Chatbot for E-Commerce. So can you please start with your presentation? Meanwhile, we can go on to the next presentation. I'd like to call Mr. Atharva Jagdale for his paper titled Empathetic Response Generation using Big Five Ocean Model and Gen AI. So please, can you start with the presentation? I'd like to call Mr. Adarsh Singh for his paper titled English Sentiment Analysis using LSTM GRU with 1D CNN. So please, can you start?
Good afternoon, everyone. Am I audible?
Yes, sir.
Yeah, just a minute. So, is my screen visible?
Yes, sir.
Yeah. So, as you know, the paper titled is English Sentiment Analysis using one LSTM URU with 1D CNN. Just a minute. So, what are the topics covered in between? The first is introduction, and it is compared with various models, and we will see the comparison matrices and the proposed model. So, an introduction, what is English? Firstly, I want to tell you that we are all using social media. As an Indian, as we know that Hindi is our national language, and most of us prefer Hindi. But when communicating through social media, we type in English, but the content is Hindi. So I used both the blend of both, that is Hindi and English, which causes some complexities and obstacles, like how to analyze someone's sentiment. Like if someone is saying, uh, "What are you doing?" in Hindi, like "tum kya kar rahe ho?" So there can be many sentiments of that. So I have tried to optimize that thing. The primary goal was that. So moving on to next slide. Uh, these are taken from literature reviews only. So the first model was that currently this model shows what it was doing, that is by taking the data from GitHub. The text was from Bangla, and then it was preprocessing the text. After that, it was various APIs were used in that while preprocessing, and after that they are using various models to train the data and validation and test. And after that, they were comparing many models. But there were some key points that it was only on aspect-based sentiment analysis, and performance was not so good because they were not applied as I written here: stopper removal, tokenization, and lowercase conversion, and also with lemmatization. So let us move at next model. So this model did emotion recognition. Like you can see the table, there are number of instances for each emotion, and it provides fastest and embeddings on two different data sets. So there were some key points, but what were the limitations? It only focused on code mix data, and they only relied on hashtags for a proxy of emotion labels. And now the question is, what is proxy for emotion labels? Like we some of us use in the text hashtag something like that, and after that we write some text. So this is known as proxy for emotion labels. Now moving on to the next model. So it shows inconsistencies between the review text and the rating score. Like if there's a given a certain text and there can be a review score, that what kind of text it is. If I can generalize that, we can generalize in 0 for negative, 1 for neutral, and 2 for positive. So it worked on this type of data set, and various vectorization was done along with lemmatization and stemming to uh, for this data pre-processing. So it was good for that, but there were some key limitations, that review rating was mismatching. Now, how is it happening? Like if some text was in positive instance, so but the rating score is given as neutral or negative. So there was review rating mismatch, and data source was limited, like up to 1,000 instances only. So these were some key limitations. Now moving on to next model. Uh, in this model, they were taken the data from GitHub, and after that they preprocessed it along with vectorization, and finally, as the data was not that much raw, so they directly pulled up to model training and testing, and after that evaluation. And as you can see, they achieved pretty good much accuracy, but there were some uh, key limitations, that no comparison of proposed deep neural network model. Now, what is that? They did not compare their model with any of some other pre-existing models, and they does not provide any qualitative analysis, like on comparison metrics that we technically say from confusion metrics like accuracy, precision, recall. So this was I found this was some limitation. Now, what comparison metrics from my side were done, that is accuracy, precision, recall, F1 score, sensitivity, and specificity. I think we all know from that, so I will skip this part. Now, my proposed model was LSTM with GRU along with 1D CNN. Now, why I took that? Why not only LSTM? Why not GRU? Or why not only 1D CNN? Why is that? Because my dataset contained of only around 3,000 samples. So it was a vast task for me to, it was around taking only LSTM can be, the result can be for underfitting only, or taking only GRU can also be resulted in underfitting. Now, I use L1 regularization along with 1D CNN, and also I reduce some of dropouts layers. So I get some better results. So this was my proposed model. Now, what are the applications? First applications is, as I told you previously, that we all communicate in English text, but the context is from Hindi. So language modeling, machine translation, and speech-to-speech recognition can be some general applications. How is that possible? If we deploy the model, then it can be further extended to recognize the emotions that I previously also told with an example, that what are you doing can be self-contained in various contexts, can be taken in various emotions. So that was the key thing. What was the this was my workflow. The data from was IIT Bombay corpus. You can also Google it from naming Hinge dataset. Then pre-processing was done. Then after data cleaning, in data cleaning, various things were done also. Data pre-processing, I forgot to add stemming and lemmatization. So sorry for that. So moving on to the next part, I did EDA, that is exploratory data analysis, and data was split into three parts. Actually, it is shown in two parts: training, testing, and validation. That is 80 is to 10 is to 10. After that, we used hybrid LSTM CNN model, and that is a hybrid LSTM plus GRU with 1D CNN. After that, we evaluated our performance. So that was from my side. Thank you.
Okay, Adarsh. I want to ask, what were the features you took for the training and testing purposes? I mean, the data set features.
Yeah, ma'am, that's it is a very pretty good question because I in the dataset there were not so many features. It was only average rating and disagreement. What can be I mean by average rating, that user has given a rating that how can a sentence, the sentence is given and how much it is the machine is translating, how much pretty good. Like if a sentence is a positive sentence and the machine is pulling it up to positive intimate, so it is pretty good. So the average rating is given by the user only, who has given the input. And disagreement feature was uh, how much the machine is not learning. Like if the machine is given some error, so up to how much extent it has given some error.
So how did you do the error analysis of your system?
Error analysis was done by ma'am from mean squared error and RMSE. Before that, I want to tell you that we did data augmentation also, and we process the data along with that, so that the model can learn more effectively, so that it can uh, what I can say, it can reduce the chances of that errors that is present in the data set.
Okay. Okay. Thank you.
Okay, thank you, ma'am.
Thank you for your presentation, sir. Moving on next. I'd like to call Ms. Siddhi Firodia for her paper titled Multimodal Emotion Recognition, a review paper. Ma'am, can you start with your presentation?
Yes, ma'am. Is my screen visible?
Yes, ma'am.
Sorry, ma'am. Is my screen visible?
Yes, ma'am, it is visible. We can start.
Thank you, ma'am. So, good afternoon, everyone. I am Siddhi Firodia, and today I'll be presenting on our topic recognizing human emotions through body language and speech using AI, that is and my group Sri Dande, and our project guide is Mrs. So these are the contents which I'll be covering in today's presentation. So I'll start with the introduction. So as we know, artificial intelligence is evolving rapidly and AI is becoming part of our lives. But one major challenge which remains is how AI or how machines can understand human emotions, an important role in communication. Yet most AI systems struggle to interpret them accurately. So, by analyzing facial expressions, gesture, posture, and speech patterns, AI can detect emotions and understand human behavior better. So, it has its applications in customer service, healthcare, social robotics, and mental health support. So, let's explore human emotions. So, in the literature survey, we have gone through many of such papers on AI-based emotion recognition. While many studies focuses on either facial expressions or speech independently, very few of the studies have been done on multiple modalities. So, this highlights a major gap in the field of emotion recognition, where multiple still missing. AI struggles to analyze emotions accurately across diverse different cultures and complex emotions. So it has been found out that most of the research focuses on individual modalities. So these are the papers which we have gone through. So the gap finding, like progress in emotion recognition has been, we can say, is done in most like in advance, but main one gap is like limited accuracy of the emotion detection across diverse culture and social context. Another challenge is that the AI system cannot detect mixed emotions of the the person. If someone is saying like he is fine, but if the tone of the emotion is like anger, so it can't interpret that emotion. Also, additionally, the main gap, which is that it cannot combine facial expression and speech together. So our research aims to address these challenges by developing a more advanced and adaptable system. So the motivation behind this research is simple. How human emotions to interact effectively. In healthcare, AI can detect signs of depressions or how the patient is feeling, so it can detect that. In customer service, it can respond more empathetically, like if a customer is angry with the service, so it can tell to the agent from the company side that the emotion of the customer is in anger, so we can user with some calm voice. And so our goal is to create AI that recognizes emotions accurately. Yeah, so the problem statement, like despite AI's advancements, emotion recognition is still inaccurate in many cases. Most of the systems have limited data sets leading to biasness. Also, they analyze facial expressions or speech separately rather than combining them. So the scope and objective, like the scope is to developing an AI model that integrates speech, facial expression, and gestures together. Real-time emotion detection in dynamic environments, application in healthcare, robotics, and customer service. And the objective is to develop a robust AI system that will integrate these three features together to provide more accurate. Also, it will work in real time and it will handle complex emotions or mixed emotions. So this is the system architecture. So this we have created this with deep learning techniques. So there are three layers: input layer, logic layer, and output layer. So first, the input layer, we will give input in the form of video. It will send audio and video. So the audio, so the the reprocessing will be done from the audios, and the features will be extracted which are important or useful. And from the video, frames will be generated, and those frames will be passed to the Convo 2D model. So we can say it will convert, extract shape or of the user. After that, the both audio and video will be passed to LSTM. So LSTM is basically, it is a type of neural network that understands time-based patterns. It will extract patterns from the data. So after that, the LSTM will pass this output to the dense layers. It acts as a final. It will combine the results of Convo 2D and LSTM. So, so the dense layer will classify the final emotion of the user. Once it has been done, it will go to the output layer, that is emotions classified. Here we will use late fusion. So late fusion is basically, it combines the output and it will give us the final emotion classified. And validation is that we will check whether the system is working correctly. Yeah, so this is the description for the architecture diagram. For feature extraction, we can use MFCC, spectral contrast, chroma, or LSTM. For video processing, like convolutional neural network, LSTM dense layers. Fusion strategies like late fusion, and validation and matrix like cross validation. will test the model on different parts of the data to ensure it performs well. And for confusion matrix shows how accurate the model is by displaying the number of correct and incorrect predictions of for each emotion. So in conclusion, our research advances AI's ability to understand human emotions more accurately by integrating speech, facial expressions, and body gestures. This technology has the potential to improve healthcare, robotics, customer service, and mental health monitoring. These are some of the references which I have used. That's it from my side. Thank you.
Okay, I want to ask, like, for this research, why did you choose only LSTM-GRU with 1G CNN?
Sorry, ma'am.
Why? What are the reasons to? Just a minute. Just a minute. Okay, what are the future directions for your work?
Ma'am, as we have found that there is gap, like nobody has done the research on these three combinations together. Like, so we will try to overcome the limitations, which is like the struggle with diverse culture expressions. Like it changes, like people have different cultures. Also, data privacy concerns also comes like. It needs consent of the user. Also, mixed emotions is still not, AI is not able to interpret that. So we will try to overcome that gap.
So, have you collected the data set for the same?
Ma'am, as of now, we are currently working on Rabbit's data set for audio and speech, like speech and video. And for body posture, we are still finding data.
Okay. Thank you.
Thank you, ma'am.
Thank you for your presentation, ma'am. Um, I sincerely thank all our authors for their
Hello,
for the
Richa.
excellent presentation. Sorry.
Yes, Richa.
Yes, ma'am.
अनिकेत गुप्ता का presentation हो गया है?
एक minute. Aniket. No, sir wasn't available. I mean, he was not there in the meeting that time.
Hello, ma'am. Sorry to interrupt. Ma'am, I didn't got any mail regarding like which virtual room I need to enter. So I was waiting in virtual room A.
Okay,
Then I
no
got to
problem.
know like
You can present it now.
sure.
You can start with the presentation.
Okay, ma'am. Let me share my screen. Uh,
Hello.
yes, I'm sharing my screen. So ma'am, my screen is visible. Hello. Hello. Hello, ma'am. My screen is visible.
Yes, sir, your screen is visible. You can start.
Okay, sure. So ma'am, our topic was EchoCart, or the voice-based chatbot for an e-commerce website. So basically, our main aim of creating this project was uh, the like sorry like a domain of a project was basically it is a project based which focuses on customer care services on an e-commerce website where basically we saw like there are many e-commerce websites where there are chatbots, but they aren't for like everyone to easily to use, because there are many people who don't know like how to communicate for any issue regarding their product, or if they have any issue what is the product and what are like its requirement. So for that we analyzed this and we created a project where it understand like customer needs and provide response for that as per that. So our problem statement is let's discuss why it was necessary. Many e-commerce platforms struggle with like inefficiency or robotic chatbot interaction. Uh, there is a generic response, or sometimes the chatbot isn't replying to the response we need or what are required. It gives something other error or something another response, which is like uh, not a like many frustrated users due to the poor understanding of these queries. Like they get irritated and like they blame the product or anything, even the product might be good. So for that,
అయిపోయిందని చెప్తుండే ఇంకా కొన్ని పేపర్స్ ఉన్నాయి కదా మావి
so for that, so the so our
షెడ్యూల్ చేసినప్పుడు ఇప్పుడు షెడ్యూల్ లో ఇచ్చారు అందరికి తీసుకుందా నాకు తెలుస్తుంది ఇప్పుడు ఒక అతను
ma'am,
చెప్పలేదు అంటే
hello, ma'am, are you saying something?
No.
No, like okay, okay, fine, fine. So objective of our project was to solve these challenges. Our system was designed to develop a chatbot or a IVR system that interacts naturally with users, train AI model to classify intent and extract keywords, key details and queries from that, and integrate across platform like chat, social media, and phone support, ensuring the scalability to handle thousands of like queries simultaneously and enhance customer satisfaction and for better engagement to a website or application. So our system is designed for e-commerce business looking for improving automated customer services. The key area like we focused are like automating and reducing the human efforts by directly answering the question with a like if there are repetitive queries, uh, the answers would be like for that predefined properly, and it is scalable if for handling high traffics, and it would be efficient for that as well. Uh, Business value like it reduces the cost and improve customer satisfaction as well, which would be valuable for business or an website. So our methodology, how we worked on the project was, we first defined like what are the requirements and what are the need we are required. Then we started to collect data. Then apart using that, we created our own data set for a specific e-commerce website. We have taken as an example of a furniture website where we collected as many possible queries we can generate, and we converted that in a JSON format. Then we created a model using PyTorch and NLTK, where we perform natural language processing and tokenize each word and store it and give a specific response for that. So we trained a model using PyTorch, and also we evaluate a metrics apart, including that. And due to our iterative development, we use multiple models, but PyTorch is the one which help us to generate a proper uh, uh, with better accuracy and proper model. We also created an interface using HTML, JavaScript, and CSS, uh, in which we integrated our chatbot, and then we deployed it. And it was like last stage was where we monitor and maintain what are the issues and everything, what can be possible for the future changes. So here are the literature where like we had gone through, which were very useful. The first there are paper titles where like there is chatbot and uh, like and what were the flaws in that. We try to overcome that gap between everything, uh, and we use this like papers to like for a better reference for creating our model, and which is better model for our uh, project. This are the few papers we referred. And here is our system architecture, how it's worked. So basically, when we enter query to the chatbot basically uh, gives it to the API. The chatbot even can take the query in a text or a speech format. If we give it in a speech format, it will convert it into a text and it will give it to the NLP for processing. Then it would generate a response from the JSON data. Then it will give a response as a chat as well as speech parallelly. So basically, it's a like a voice chatbot which can take an input as a voice and give an output as a voice as well. So here are the model evaluation which we did. As we trained our own data set, so the accuracy was quite good, and precision and recall and reference score were also similar to that. So here was the interface that we created of the chatbot. Uh, uh, you can see like yeah, here is a we integrated a chatbot at below right side below of the website. And we can if we ask about we can type or we can type a message or query. If we select on speech, we can ask him a question. He would respond in chat as well as in voice based. So to summary that we have developed an AI chatbot that classifies intent and extract the detail accuracy, improving response efficiency of a customer engagement. Looking ahead, we have enhanced to system like improving the text-to-speech accuracy for a voice integration, adding multi-language support to cater this for customer base. If there are like to add local languages if possible, uh, uh, and enhance the real-time query handling, faster responses as well. This would be very useful for a real-time application if it is properly. We can implement like how we decided it. And here are the few many references like we used as well. This were a research paper we used, and I would like to say that this project is a potential for like transforming customer care support and their experience by making it smarter and faster and more engaging for the customer. Thank you for your time. I would like to hear, and if you have any question, you can ask.
Okay, I want to ask whether you have compared your work with any other existing research works also?
Uh, as I mentioned, there were few papers we used for reference. We took reference of that paper and fill the gap which they had. Like a few of them have there was in sentiment analysis, uh, they weren't understanding like what the user exactly the query was. uh, and a few of them they have a chat basically like basic chatbot, and so we try to implement it in a voice speech format. So this there are few gaps we try to cover which they didn't have.
Okay, okay, thank you.
Sorry to interrupt. Actually, your topic is very fabulous. Actually, I have a query. So can
Yes.
I ask?
Yeah, sure.
Can you just let me know how contextual understanding is working in your chatbot?
Like you're asking like how the data is manipulating.
No. Contextual understanding. Like how, if I give a sentence as input, so
Yes.
in which context will the chatbot immense it?
We have applied a sentiment analysis where like it will decide like how the statement is, or if the person like we have said some few words like which will determine how the person sentiment is like. It's like it an anger or we haven't used it for a vast thing, but we haven't used it for like a small purpose. Like if the person is happy, like there are few words or few something which can easily determine the whether the statement is a anger or a happy kind of, you can say.
Okay, thank you.
Well,
Thank you for your presentation, sir.
thank
Next,
you,
I'd
ma'am.
like to call next I'd like to call Ms. Shaga Anusha ma'am for her paper titled Federated and Deep Learning Techniques in Medical Imaging. Ma'am, can you please start with your presentation?
Yeah, ma'am. A very good afternoon, ma'am. One second. Ma'am, is my voice is audible? Hello.
Yes, ma'am, it's audible.
And my screen is visible, ma'am.
Yeah.
Yeah, okay. A very good afternoon, all. First of all, I would like to say very thanks to SmartCom 25 for giving this opportunity. And I am Shaga Anusha. Today I'm going to give a presentation on title. My title is Federated and Deep Learning Techniques in Medical Imaging, state-of-the-art innovative approaches for brain tumor segmentation. And this is what outline I would like to go through these things. And introduction, background, federated and deep learning methods for brain tumor segmentation, challenges in deep and federated learning, conclusion, and finally references. And this is what introduction here. See, first thing is this brain tumors are caused by abnormal cell growth in a brain. So due to this abnormal cell growth, the brain will be affected seriously. These cells may be a benign or malignant, we can say that, which will can be harmless or dangerous, and so they can lead. The cells can lead to serious problems like on brain, like difficulty in brain functioning, and it can be lead that even deaths also. So the main importance is diagnose this brain tumor very effectively, finding this tumors effectively, so that we can give the proper treatments and doctors can lead this problem very easily, and they can find the treatment very easily. So one of the most important thing is the visualization, image visualization. So to find the tumor, the image visualization plays an important role in this. For that, we are taking this MRI and CT scans, and see, in these healthcare settings, we are mainly facing the challenge. A difficult challenge is a restriction of quantity of data. That is the main challenge we are facing. So when in that case, this federated learning comes into the picture. That this is a main promise. This is a very good promising approach. That problem which here different organizations are works together and training a single global model without revealing any sensitive information. How this federated learning works, what is the function of this federated learning means, this federated learning, it improves this model performance while keeping sensitive data private. Means in this entire process we are taking some medical images, right? So some person's medical data we are taking, so on that only we are training and testing, all we are doing. So we are providing some security by using this federated learning methods. So the privacy, the security is providing by this federated learning. So in this, for developing that model, the multiple organizations are comes together, works together, and they are giving some updates into the central server without sharing their local data. That is what they're doing here. And here we have a lot of data in we are working on the deep learning has a lot of data here, but advances to a lot of automatically detecting brain tumors, but there isn't much research on this federated learning specifically for this purpose. That is the reason this federated learning I've taken. And focus of the particularly for what is the focus of the study is completely, the study looks at very current methods for identifying brain tumors using MRI, and particularly explores combining federated and deep learning techniques using this MRI data segmentation purpose. And here, this is what background work I have taken, combining how this combining of federated learning and deep learning methods. We have solved a few we have solved a few challenges we solve the problem of isolated medical data which stored in a separate institutions. So it enables training models for brain tumor detection while keeping patient data private. So that is how we can use by the combination of this deep learning and federated learning techniques. And in this federated learning, each institution trains a model locally using its own brain scan data instead of sharing the actual data data, they use it to share the updates to the central server, like training results, which comes to the training results. And the server combines these results and to update the global model. That is how the work is going on in this federated learning. And what are the challenges we face in this federated with the federated learning in medical data is, so when it comes to this when we are using some data sets, when it is that the data set is in incomplete, or else we can say that medical images, incomplete data set, or else we have some medical images data sets like scans from different devices or types. So this work, it will be very difficult to process the data set. In that case, this work is focused on this overcoming these challenges in decentralized group setup. So that is how, and this using these federated learning basic techniques, we can use some methods like using central server for coordination, can manage the distributed training process efficiently. These basic technology can still effective, can be can for the task. And this is what literature have done. A few of things I kept here in the table. And first, friends, in the 2023 they have given this, and the methodology they used enhanced UNet and dataset BRATS. They have used like brain tumor segmentation challenge dataset. It was a and with the limitations they have found requires extensive computational resources like hardware equipment may overfit on small data set. That is the one of the limitation they found. And these are the few things I kept in this table. Methods, whatever the methods we used in this federated and deep learning techniques for brain tumor segmentation, are we choose the most representative and well established methods for various group federated techniques like we are using. We detail each along with necessary adjustments. And when coming to the federated learning, this federated AVG was suggested. First thing, to in a proposed structure for collaborative training would be divided into multiple communication rounds like FedNova, FedAdam, Fed AVG. These are the few methods they have proposed. And deep learning, this in coming to this deep learning has a plays a very important role for the segmentation purpose, classification purpose in medical area. So here in this deep learning, we are taking one of the most important type like CNN algorithm. We are taking by image based process. So for segmenting brain tumor from images among other image based tasks, we use CNN. And intelligent and effective for a network for designing this architecture of the model. This deep neural networks of brain tumor segmentations plays a very important role. And when it comes to there are main two types of these designs. When we model the designer, there are two different types of network designs we have, like encoder decoder networks and single path and multipath networks. When it comes to the what is this encoder decoder and single multipath networks, see this encoder single path networks, we were focusing on extracting features from input image and classify the center pixel, whatever there in the image, that will we are going to classify in each image. When it comes to the multipath networks, these are more advanced because they process features at multiple levels or scales. So this helps them combine local details with global context, making them more powerful for brain tumor segmentation. So that is how they are using in this multipath. And when it comes to the comparing with the single path networks, multipath networks are very powerful because they process features at different scales like local and global information combining. And this is how I would like to explain this single path CNN and inner two path CNN, how it works in brain tumor segmentation. First, they are taking that input data, and without in this single path, what we just now discussed, like extracting features from input and classifying the center pixel of the image. So first they are taking input image and convolution layer they are applying, in fully connected layer we are getting, and after that single path CNN without fully connected layer we have we are converting this. And finally,
Excuse me, ma'am, just a gentle reminder that 7 minutes are over. Can you please?
yeah, ma'am. Yeah, ma'am, sure. So next, coming to this challenges, what are the challenges we are facing in deep and federated learning? First thing is the availability and quality of data for doing research purpose, and to take the data and for providing privacy that particular data, that is security, providing security of the data. That is also one of the big challenges we are facing, and one more few challenges like computational requirements, hardware requirements, model generalization. The model should work in any new and big data and communication overhead. In federated learning, they use it to communicate like local server, global server. That connection should be clear, and privacy security concerns for providing the data and resource management. So these things are the main challenges we are facing in this deep and federated learning. When coming to the conclusion, see, in this conclusion, advances brain tumor segmentation has improved a lot, and thanks to new technology techniques like deep learning and federated learning. In this review looks some at main methods using multimodality imaging and ensemble methods, cascade networks, pre-trained models to get already we are using models already trained for the particular tasks, and we are using in this to get a more accuracy, improve the accuracy. And we are identifying what we are identifying research gap is more research and is needed and offers ideas for future studies. And one more thing, the better solution. These technologies have a potential improve segmentations, accuracy, and tumor detection, make models more adaptable for different situations. They also help protect patient privacy while analyzing brain tumors, offering more reliable solutions in futures. That is how the conclusion, and these are the few references I kept here in the presentation, and a lot I put in a paper. And from these papers, I have gone through all these papers, and I have got few idea about it, and I put in the presentation. That is how from my side. Thank you.
Okay, thank you. I want to ask, you have provided this literature review. So there is an issue of data heterogeneity. If we see that heterogeneity across different healthcare institutions, so how do the reviewed studies address this issue?
Means, madam, you're asking about means security.
Yeah, data heterogeneity. If
madam.
data is heterogeneous, and if you're collecting the data, etc., from different healthcare institutions,
Yes,
so
ma'am.
whatever studies you have provided, so are they using some heterogeneous data, or they were working on a small data set or a similar type of data set? So can you please explain that?
No, madam, it is not related to like small data set and all. It is completely we are taking real time, like we use it to take number of organizations are working together at one server, and they have to collect the data, patient data, real time they are taking, and on that data they are going to develop that model, particular model. So for that data, we are providing the security using federated learning methods, techniques.
Okay, so are you planning to extend your work? I mean, you're implementing
Yeah,
something on
yeah,
that.
yeah,
So
ma'am,
have
yeah,
you
ma'am.
collected the data set as well?
Yeah, ma'am. This is BRATS, that is the best main data set which is used for brain tumor segmentation challenges, madam. So in further papers, I would like to continue this research for implementation purpose, madam.
Okay, okay. Thank you so much.
Thank you, madam. Thank you.
Thank you for your presentation, ma'am. So I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 9th version and all the previous 8 versions of this conference. We'll be happy to have you in the 10th version in 2026. All the presenters would be given their digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I'd like to thank our session chair.
Yeah, thank you so much.
Wow,
And
yeah.
thank you everyone for an engaging and insightful session today. It has
This
been
is a
yeah,
token
sure.
of appreciation on behalf of the team SmartCom 2025 and Global Knowledge Research Foundation. You can
Thank you so
continue.
much. Yeah, that
Thank
was
you
a
for the
wonderful. Yeah, that was a
Thank you
wonderful
for your
session.
answer.
Yeah.
Yes, ma'am.
So I just want to say that it has been a pleasure to hear from all the presenters who have presented innovative and thought-provoking research on these topics, generative AI, deepfake detection, etc. And each presentation has highlighted the exciting advancements in this field and the challenges that lie ahead. So this was all good, and all the presentations were very good. They have applied techniques, or they have implemented something. I mean, using some languages and some works, some classification techniques. So all works were really very good. So all the best to all the participants and presenters. So that was all good. Thank you so much.
Thank you, ma'am. Now I kindly request everyone to switch on their cameras for a quick snapshot. Thank you, everyone.